Okay, let's continue with a beautiful exam question. Anna, whose preferences exhibit decreasing MRRs, maximized her utility subject to her budget constraint. Then the price of the first good increased and the price of the second good decreased. Since the bundle that she optimally consumed is just affordable after the change in prices, we can conclude that she is exactly as well off as before. True or false? Well, this is clearly false. Why? Because as there are now new affordable bundles that before they were not possible, maybe it's interesting for Anna to change. Okay. Well, it would be interesting to do the graph, and that's what I did here for you. Initially, the budget constraint is the red one, yeah? Now, the optimal bundle is the red point with the indifference curve touching tangentially for the last time the budget constraint here, okay? So, when the price of X increases, this intersection point becomes lower, so we have more or less here, and the price of good Y decreases, tells us that the intersection point with the vertical axis is higher. So the budget constraint turns bad and becomes the blue one, and as the previous optimal bundle, is the red one, is affordable now, I must draw the budget constraint, the new budget constraint, the blue one, through this red point. Depending on how the indifference curves are, I could have this situation. And this situation and this situation, Anna is better off. Why? Because all these bundles here were not affordable for her before. Okay, well, were outside its possibilities. Now, she can find this bundle that before it was not affordable, and it gives her a higher utility level. Okay, so if Anna had another type of Cobb-Douglas function, or maybe the prices didn't move as in this graph, maybe she would decide not to change, and maybe she would be as well as before. Okay, but she could find this possibility also depending on these price changes and so on. So be careful with this. It could be that Anna became better than before, yeah, or whatever. Well, 32nd. Which of the following utility functions does it correspond with the demands? With these demands. These demands are the typical demands that we get from the Cobb-Douglas type utility functions. So clearly, the true is C. Yeah? Well, this is a quasi-linear. This is another type of utility function. Maybe we could think of this being true. Well, if you apply these formulas to this utility function, you could find that a, the exponent of a of x, divided by a plus 1 minus b times this is not the expression we have here for x. So clearly is false, D, and the true is C. Okay. Now, easy but important question, maybe not so easy for students. Which of the following utility functions doesn't represent the same preferences as the rest? Okay, this is a Cobb-Douglas type utility function, and it tells me, since the exponent of y is double of the exponent of x, that this consumer likes to spend the 2/3 of its income in good y and 1/3 in good x. So the double in good y than in good x. Okay, of his income always, yeah. That's the same that we have represented here. Okay, we know that if we take logarithms here, we can find this expression by changing the exponents, multiplying them by 3. Okay, so we have equivalent utility functions, because if you calculate the MRS in both of them, it will give you the same expression. If we look at C, here y is dividing by, but it has negative exponent, so I could write it multiplying with positive exponents. So x elevated to 15 times y elevated to 30. So the exponent of y is double to the exponent of x. So it's the same preferences also as A and B. So the false is this one, D, because this consumer likes to spend 3/4 of his income in good X. Okay, here I did the MRS in each case for you, and you can find this I explained you before. Okay, now the MRS in this first case is minus y divided by 2x. The MRS in the second case, we have the same. Okay, and in this case C, this is a different one, so it's false. It should be easy for you. Okay, try at home these calculations if you want, and you will find that this is easy, and this is very important for me. Okay, 34th. Suppose the following graph represents the situation of a consumer before and after a change in the price of good Y. Okay, the graph represents a decrease in PY. The graph represents a change in good Y, in the price of good Y. That's correct, but it's an increase in the price of good Y. The intersection point is M divided by PY. As PY increases, M divided by PY decreases. So clearly, we have that. Clearly, what we got is B. Okay. Well, these are the mathematical explanations, but it should be easy. 35th. Suppose the following graph represents the situation of a consumer before and after a decrease in the price of good X, from Px star to Px. Okay, so from here to here would be the change. So here we have the first budget constraint, here we have the second budget constraint. Don't pay attention to this other budget constraint. Don't pay any attention to this question. The consumer changes her consumption from D to A. Okay, as the possible answers are regarding to the best consumption bundle in each case, we will look at them. If the budget constraint is this one, the first one, I think that it's clear that the tangent solution is B. And after the change in price, the optimal bundle is C. So the change will be from B to C. Yeah. So I think this should be easy. I hope all of you have answered correctly. Okay, and let's go to the 36th. Well, the preference order according to the following graph, both X and Y are goods, is, well, A and B lay at the same indifference curve, so they are both desirable, equally desirable, sorry. So A and B are equally desirable. It should be A or B, okay, A or B. D is in another indifference curve, and it gives me utility level 2. C gives me utility level 3, so C is preferred to D, and the answer clearly, I hope, is B. Okay, well, here I wrote you the utility levels for each case. for each bundle. 37th. Alaya always consumes 3 oranges for every 2 bananas at 5 p.m. She could eat as much as she wanted, but always at this proportion. So oranges and bananas are perfect complements for her, yeah? If I have m euros to buy her oranges and bananas, the demand for bananas, for me, or for Alaya, it's the same, would be, okay, this is a perfect complement type exercise, so as I told you always, is very easy. Maximize the utility of oranges and bananas, mean 203b. Why? Because this number 3 I carry to the coefficient of b as a coefficient of b, and this 2 I carry as a coefficient of o. I usually explain this in class, why this is like this. I want to do here, okay? The budget constraint, as I didn't give you prices, we just write the budget constraint this way. Now, we know that we have to equalize both components to O equal to 3b, and I, for example, isolate O as 3/2 b, and I carry to the budget constraint. So here, where O was, I write 3/2 b. I take out b as common factor, and this parenthesis I will carry to the right hand side, dividing. Okay. Well, if I look at the answers, I don't have this answer here, okay, but I think that it's not difficult to think that we could multiply by 2 on the upper side and in the downside, okay, so that we get 2m, and here 3/2 times 2 is 3 plus 2 pb, okay. So the correct one is C, yeah, I think. No, sorry, it's A, yeah, it's A, sorry. Okay, now 38th. X is a good and Y is a bad in which of the following utility functions? Okay, X here is a good because it has positive exponent. The more X I consume, the more utility level I have. And here X is a bad because the more Y I consume, the less utility level I have. Okay, well, this is easier as it seems, so I will, it's the same, it's A, okay. Now 39th, the intertemporal budget constraint can be written like this. Well, take care. 1 plus r times x plus y equal to 1 plus r times m1 plus m2. This is correct. This is the way I like to express it. It comes from financial mathematics or finance, moving the income and moving the consumption in period 1 to the future, to moment 2, okay? So m1 times 1 plus r, I can sum it with m2 and have all the income for me considering in period 2. If I do the same with the consumption, I could, well, it should be, here it's better if you put C1 and C2, but as the answers are like this, well, we suppose that X and Y are consumptions in period 1 and consumption in period 2, okay? So equalizing at moment 2, we have this expression, and we equalize it, so A is true, okay? But look at D. It says both A and C are true, so we need to be careful. If I equalize it at moment 1, is M1, sorry, C1 or X plus Z2 times 1 plus R elevated to minus 1, yeah? We equalize this is the present value, okay, the present value of the consumptions and the incomes, okay, and the same for the incomes, as I told you, M1 plus M2, the present value, okay. So A and C are true. This C is a typical way many teachers give the intertemporal budget constraint. I suppose it's because of the present value concept, okay. I prefer to know finance, and by knowing finance, know that be clear or have clear in your minds that we can equalize at the future, okay. So it's easier if we don't have this negative exponent or divisions, okay. So the last one, I think it's the last one. The intertemporal budget constraint shifts outwards if both income from period 1 and income from period 2 increase. No. Well, sorry, yes, of course, of course, and very outward, very outward. If income of period 1 increases and income in period 2 increases, of course, the budget constraint will shift outward. If both incomes from period 1 and income from period 2 increase at the same rate, of course, it's a particular case of A. If both income from period 1 and income from period 2 increase at the same amount, of course. So there are particular cases B and C of A. So the correct answer would be all of the above. Okay. If M1 and M2 are higher than before, it doesn't mind how much, but if both are higher, this would be higher than before. So the budget constraint, the intertemporal budget constraint, will shift upwards. Even if one of them is higher than before and the other one is the same, it would be shift outwards. Think at home what happens if one becomes bigger and the other one becomes smaller, please. Okay. Okay, that's all. I hope you understand all the questions. If not, you can find me in my email, verticeinigo@gmail.com, or through Skype. Okay. We will see in the questions of Unit 2. Okay. Bye.